Tonight we are just looking at some more organic families, so just 3 more. The first one is the one we're going to see the most, and that is the carboxylic acids. They can be written different ways. Sometimes we show the functional group like all the parts of it, and sometimes we show this shortcut way. We've seen that in our lesson 7 on acids and bases. This is another way. Of course, there is a carbon right there, and if we want to name this, that would be carbon number 1. And so we would say pentanoic acid. So oic is the ending. We don't have to say a 1. We don't say 1 pentanoic acid. That would be wrong, because the functional group has to be on an end carbon for that one. Next one, this functional group is called an ester linkage, and the family name is the esters. It is kind of like an ether and an aldehyde or a ketone in one, but we don't think of it that way. The whole group is called an ester linkage. And we're not going to do too much. We're not going to do naming with those. You have to know a few, properties and common ones off your PowerPoints. This last one is the amines, and they are classified as primary if they have 1 bond that is to a carbon. If they have 2 bonds that are to a carbon, they're secondary. And tertiary if they have 3 bonds that connect them to carbons. The other thing to notice is that when they have, this one just has 1 bond to carbon, that means that it has 2 to hydrogen. And that allows these two, the primary and secondary, they have the N to H bond so they can hydrogen bond. Let's do another name of so we're not naming amines either, but let's do another name of a carboxylic acid. This would be carbon 1. Get a different color there. This would be carbon 1. That's a methyl group, of course. So in our name, we'll say 4-methyl. And the last name, pentanoic acid. Again, this is carbon number 1, but we don't need to specify that. We number according to our functional group, but of course that has to be a 1 there. If you want to pause and write these down, all I'm going to do with these is just classify by their family type. Let's see, so let's start up here. When it has just an OH, it's an alcohol. And this one is 3-pentanol. Okay, this one has the carbonyl group on an end, so that's an aldehyde. And we don't have to say the number, it is carbon 1, just counting them all. This is pentanal. This one has the carbonyl group, the C double bond O, but it's not on an end, so this is a ketone. And on these we do say the number. We say 2-pentanone. Here's our new one. Has a carboxyl group on the end, so this is carbon 1. Be careful not to number this oxygen as like a carbon. This is carbon 1. This is hexanoic acid. And then this one has it's kind of like an ether. It has the oxygen in the ring and a carbonyl group. This is an ester, and we don't name those. We're not going to name those. The thing to know with properties, and we're really going to focus on the properties of carboxylic acids, they are the best hydrogen bonders of all of the families, including the ones we did before, like the alcohols that can hydrogen bond pretty well. These can hydrogen bond better than alcohols. In particular, if you put two, these are acetic acid molecules together, they can actually connect in two places at the same time. And this is a whole lot of attraction, stickiness between two pretty small molecules. They'll really stick together pretty well. So that can happen, but also if they're bonding to water, there is a possibility of them forming many hydrogen bonds at the same time with water as well, because they don't just have this OH part, they have this extra oxygen as well. So when water is around, each hydrogen can form one hydrogen bond to water, but each oxygen can form two. I didn't draw that one. But anyway, so a lot of hydrogen bonding with carboxylic acid. So that makes them the most water soluble and the highest boiling points of the families. Of course, a primary or secondary amine has this nitrogen to hydrogen bond, and this hydrogen can form a hydrogen bond with water. And then when we compare for our properties, I won't have you compare with amines, but I will be throwing in the acids as far as comparing boiling points and stuff. If I'm going to look at boiling point, let's first look at the type of the family. And the hydrogen bonds, these are the best hydrogen bonds. Best hydrogen bonders, is what I say. But then of the two, the octanoic acid is larger, and so that makes it stick together even more. Remember that there's always dispersion attractions, so more atoms in contact when you have octanoic acid. This will be the highest of the three when it comes to boiling point. Okay, I had to add some molecules there. Let's compare water solubility of these that I drew in black. So with water solubility, the carboxylic acid definitely is more water soluble. Than the alcohol. So of these two, the acid is more water soluble, so I'm just going to cross that one out. And then if we compare these two, the smaller is more water soluble, because remember with, and not this one, so of the three, this one's the most water soluble. Remember, when it comes to water solubility, what matters is hydrogen bonding. You want lots of hydrogen bonding. And you want smaller CH part. The CH part is hydrophobic.